Topic 3 is on arc length and central angles. We know that 1 degree is exactly the same size regardless of the size of the circle. This also needs to be true for radians. The consequence is that radians can measure a circle of any size. We made the initial definition based off of a unit circle that had radius of 1, but we can use the fact that from geometry we have an arc length to radius ratios are equal in circles. So we can use that to talk about arc length in terms of radians of any size. Circle. So, for example, this arc length to radius ratio would look like in the inner circle where the radius is 1, the arc length we've called S1. So S1 over 1 is equal to the outer arc length of the same angle is S divided by R. So since it's over 1, we have that S1 is equal to S over R, and that S1 is the angle in radian measure. So if we talk about this in terms of the angle in radian measure, then we can talk about this in terms of, let's call that angle theta in radian measure. This is only true in radian measure, of course, but theta is equal to the ratio of S divided by R. Okay, as long as your angle is in radian measure. So therefore, provided we use radians as our measurement for an angle, we can define the size of that angle as a ratio of the arc to the radius. Cool. Okay, so in example 4, we're going to fill in this table that now relates to relate the distance around the arc length, the radius, and the angle. Okay, so as seen in this picture right here, we have the distance around the arc, our S, we have our angle, and we have our R. We want to relate those three things to each other. All right, so if I have a distance around an arc length of 200 and an angle of 45, I can solve for R. So I'm going to write off to the side right here that the angle is 45 degrees. I cannot use 45 degrees. I can only do this in radian measure, but I can go ahead and convert that into radian measure. So that would be 45 degrees times pi over 180. It's going to come back out as pi fourths in radian measure. Then, to compute the radius, we know that the angle, pi fourths, is equal to S, which is 200, divided by R. So if I multiply the R over, divide the pi fourths over, we'll be able to compute the radius. So the radius is going to be equal to 200 times 4, that's 800, divided by pi, and then if I just approximate that division, we can get an approximate measure for the radius. So 800 divided by pi is approximately 254.65. That would be the approximate radius in centimeters, since I do have units on the distance over here. Hold on. Alright, let's look at the next one. This time we have an angle that is 5 pi over 12. It's already in radian measure. So I should be able to compute the arc length with the radius here. And so the arc length S is unknown. I have my angle of 5 pi twelfths equals S over 4.2. If I multiply 4.2 by both sides, we'll be able to solve for S. So I'll do that over here. So I can type in 5 pi over 12, and I just need to multiply both sides by 4.2. So that gives us a S of 5.50 if I round to two places, 5.50, and this one was in inches. All right. And then the last one, I want the angle, and so I know that the angle is going to be S divided by R, so that's 3.5 divided by 8. I can just use my calculator for that division. 3.5 divided by 8 is 0.4375. So that's 0.4375 radians. I don't have to write a unit for radians. It's just already in radians. And usually our radians are in terms of pi. if I had my way about it, but I don't in this case because I didn't have a way of writing this in terms of pi. So it's an odd way to write a radian measure, but it is a radian measure. Okay, we'll pause here and talk about topic 4 in the next video.